Hi everyone, Miss Craig here again. We are now starting lesson 2 of the week of April 13th through the 17th. This is our Learn About It section for inscribed angles. We're going to start with a few definitions. So the first definition is a chord. So a chord of a circle is a line segment where both endpoints lie on the circle. Next is an inscribed angle. So an inscribed angle is the angle that's formed by two chords versus the central angle, which we did last week. And next is the intercepted arc. So the intercepted arc is the arc that's formed from an inscribed angle versus last week we did the arc that was formed from a central angle, which was our minor arc. Today we are focused on the arc that is from the inscribed angle. So the theorem we're going to use is the inscribed angle theorem. So the inscribed angle theorem is telling me that the angle inscribed of the circle is half the measure of the arc. So if we have the inscribed angle DFE, it is going to be half the measure of the intercepted arc DE. So again, if we have the inscribed angle ABC, it is going to be half the measure of AC. So in order to apply this, we would first write down our inscribed angle theorem to show the relationship, substitute whatever values we have, and then solve for that missing value. So now we're going to apply this to some problems. So we want to find the measure of PRU. So if we're trying to find PRU, we want to write the relationship between the intercepted arc in that inscribed angle, which is PU. So we would write down our theorem, which again is the measure of the inscribed angle, which is PRU, is equal to half of its intercepted arc, which in this case is PU. Then we would fill in our values. So we don't know what the measure of PRU is equal to half of PU, which is 118. And then we would do the math. So the measure of angle PRU is equal to half of 118 degrees is 59 degrees. So on the next one, we are trying to find the measure of SP. So we need to make sure we know which inscribed angle goes with that intercepted arc. So the inscribed angle that goes with that intercepted arc is SRP. We're going to write our relationship. So the measure of the inscribed angle, which is SRP, is equal to half of the arc SP. So we know the measure of the inscribed angle SRP is 27. It's going to be equal to half of the intercepted arc SP. So now we have to solve for that arc. So to solve, we'd have to multiply both sides by 2. And when we multiply by 2, 2 times 27 is 54 degrees, is equal to the measurement of the arc SP. For our next example, we want to find the measure of the arc ADC. So we're going to mark ADC. And we need to find the inscribed angle that goes with that arc. So the inscribed angle that goes with that arc is ABC. So now we can write our inscribed angle theorem. We'd have the measure of the inscribed angle, so the measure of angle ABC would be equal to half of the measure of the arc, which is ADC. We'd fill in our values. So the measure of the inscribed angle ABC is 135 degrees, and that'd be equal to half of the measure of the arc ADC. And then we would solve. So in order to solve, we have to multiply both sides by 2. So 2 times 135 is 270 degrees, is equal to the measure of arc ADC. On the next one, we are trying to find the measure of angle DAE. So here is my inscribed angle DAE. We want to find the corresponding intercepted arc. So my corresponding intercepted arc is DE. So we're going to write down our inscribed angle theorem. So the measure of the inscribed angle DAE is going to be equal to half of the measure of the intercepted arc DE. Going to substitute in our values. So we don't know what the measure of angle DAE is equal to 1/2. The measure of the arc DE is 76. Do the math. So the measure of DAE, to simplify, 1/2 of 76 degrees is 38 degrees. Next steps, you'll go on to the try it pages. There'll be more practice for you to do, and then eventually you'll do the show you know. Hope you're all safe. Take care.